Hello, my name is Karim and today we're going to talk about composite materials for aerospace engineering. First of all, what is aerospace engineering and what makes it different from the rest? Aerospace engineering is a branch of engineering that deals with the development and construction of aircrafts, spacecrafts, and satellites. Such discipline integrates the engineering concepts and material science in order to create optimum aerospace structures. Previously, in the aerospace industry, metals were the most used materials for the construction of these vehicles, which made them heavy and required a lot of fuel to transport people and cargo. This fact made aircraft designs inefficient. But a new material came into the light, which is composite materials. So what are composite materials? These are hybrid materials created by combining two or more materials in a structure while remaining separate, which results in a new product with desirable properties such as high compressive strength, flexibility, and hardness. Some examples of these materials in the aerospace industry are fiberglass, which is mainly composed of silicon dioxide, aluminum oxide, and calcium oxide. This material is relatively cheaper, stronger, and more flexible than other materials by weight. Fiberglass is now used to reduce the weight of everything from plain chairs to laboratories to overhead bins. Additionally, we have metal matrices, which are composed by at least one metal and other materials that don't necessarily have to be metals. This is done to come up with a new material with the physical and chemical properties of both materials combined were needed within an aircraft structure. This is why metal matrices are used to make high-stress parts of aircraft such as engines and landing gears. Carbon fiber reinforced polymers, which is essentially a structure of carbon fiber set in plastic. Those tend to have high strength-to-weight ratio, and this is why it is used in wings of aircraft and other vehicles such as sport cars. Lately, the demand of these materials in the aerospace industry have considerably increased because these materials allow engineers to come up with lighter and faster aircraft designs, which will require less fuel and therefore will pollute less than other conventional airplanes. Companies such as Boeing from the United States and Airbus from Europe have come with new aircraft that are mainly composed of these materials, such as the Boeing 787 Dreamliner, which has a capacity that ranges between 250 and 290 passengers, a range of more than 15,000 kilometers, and a speed of 954 kilometers. On the other hand, we have its competitor, the Airbus 350, which has a capacity between 300 and 350 passengers, has a range of approximately 15,000 kilometers, and has a speed of 954 kilometers per hour. Conclusion: it is a matter of time that engineers and scientists come up with new designs that overcomes the current modern designs, such as lighter, faster, with longer range than the current aircrafts. However, due to the flexibility of these materials, they can also be used to make other things, such as cars, trains, ships, and buildings, to name a few. This is why it is up to us to use these new materials and innovate to come up with new things that will improve the performance of all mankind structures, as well as our quality of life. I thank you so much for your attention, and I hope this was useful for you to consider composite materials in your future projects as engineers. I hope you have a great day. Bye bye.